One of the most common senior engineer interview questions is, your API returns thousands of records and the system is slow. What do you do? In this video, we walk through the exact patterns and trade-offs you need to answer that question like a senior software engineer. Here's the situation. The client calls GET orders. The API runs a select star against the database. The database returns 50,000 rows. The API serializes 80 megabytes of JSON and sends it back. The client either times out or runs out of memory. This is the problem we are solving. The first pattern is pagination. Instead of returning all records at once, you split the dataset into pages. The client requests one page at a time using query parameters, page and size. This immediately reduces payload size from 80 megabytes to a few kilobytes per request. There are two types of pagination. Offset pagination uses skip and take. It is simple to implement but gets slower as the offset grows, because the database must scan and discard all skipped rows. Cursor pagination uses the last seen identifier as a pointer. The database starts exactly where you left off. It does not slow down at page 500. For large datasets, cursor is the right choice. The second pattern is filtering and projection. Filtering means you only return records that match specific conditions. For example, active status, a date range, or a category. Projection means you only return the fields the client actually needs. If the client needs 3 fields, do not serialize 30. These two techniques alone can reduce payload size by over 90% before pagination is even applied. The third pattern is caching. On the first request, the API queries the database, stores the result in a cache like Redis with a time to live, and returns the response. On every subsequent request for the same page and same filters, the API returns from cache. No database involved. Response time drops from seconds to milliseconds. The trade-off: cached data may be stale. You need to define the acceptable staleness window for your domain. The fourth pattern is streaming. Instead of waiting to load all records into memory before responding, the API sends data in chunks as it reads from the database. The client starts receiving and processing data immediately. This removes the memory spike on the server and eliminates the timeout risk. The trade-off is complexity. The client must handle incomplete responses and the server must manage the stream lifecycle carefully. Here is the trade-off map. Pagination and filtering are low complexity and should always be your baseline. Caching adds medium complexity but delivers the biggest latency win for read-heavy APIs. Streaming is the most complex but the only real option when clients need to consume all records, like a data export or a report. A senior engineer does not pick one pattern, they layer them. This is how the interview scenario looks. The interviewer asks, your orders API returns 80,000 records and it is slow. What do you do? The weak answer is, add pagination. The strong answer is, first, add pagination and filtering as the baseline. Second, add caching for frequently repeated queries. Third, if clients need bulk data, introduce streaming. Then measure. You do not stop at one pattern. You layer solutions and validate with data. If this helped you, follow at capacitaDEV on Instagram and TikTok for more senior and staff level interview content every week. Like this video and share it with someone preparing for their next technical interview. And check the link in the profile. There is a free PDF with 20 interview questions across junior, intermediate, senior, and staff levels. It is completely free. Go grab it.